All right, it is the last day of solving equations, and we're going to talk about solving literal equations. So, this is exciting. But a literal equation, we'll talk about in a second, but it's a type of equation kind of like a formula. So, what I'm going to have you do here is I have a little exploration portion where I want you to um, use some of these formulas that you're familiar with. I got a perimeter, area, volume. I want you to go ahead, plug in the values I've given you and see what you come up with. Okie dokie. So here I've asked you to find the perimeter of a rectangle. I gave you the formulas for all these. Something with a length of 2 centimeters and a width of 3 centimeters. All right, so what I'm going to do is plug these gears in. All right, so I'm going to plug in length where that L used to be, and I'm going to plug in the width where that W used to be. Then I'll multiply. So this will be 4 plus 6, which is 10, and then I'm going to put centimeters, right? Don't forget your units. I'm going to tell you a quick story about units. So one of the first schools I worked at, we had a Google form that we could fill out if we needed supplies from the supply room, and they'd have student assistants that would bring them to us. And so I needed pencils one day, and so I filled it out, and I said I wanted 5 boxes of pencils. And the Google form said, just said pencils, and then when I typed in 5 boxes, it said it only took numerical answers. And so I removed boxes, and I just typed in 5, and then it let me submit the form. Like an hour later, the student assistant comes to my room with exactly 5 pencils. Because I thought the unit we were talking about, right, was boxes of pencils, and the unit was really individual pencils, right? So boxes versus pencils, right? Huge difference, right? So don't be like me with the 5 pencils. It would be quite sad. All right. So next, area of a circle um, with a radius of 4 feet. So gonna go ahead, plug it in. My area is equal to pi times something squared. I'm gonna plug in 4 here. So I'm gonna get out 4 squared is 16, and so 16 pi is my answer here. All right, and last but not least, volume of a rectangular prism with a length of 2, a width of 4, and a height of 6. Oh, all right, so lots of color coding going on here. So we've got length 2, width of 4, height of 6. All right, so 2 times 4 is 8, times 6 is 48 inches, and this will be inches cubed. Guys, I just told you my story about units, and then I forgot my units in the last one. Oh my goodness. See, look, that's alright. Mistakes happen. Just kind of ironic. It's right after I said, hey, don't forget your units. How many of you at home are chuckling? Oh well. Alrighty. Alright, so we can find the perimeter, area, and volume above by using these formulas, right? Formulas are a special kind of literal equation, which is an equation with 2 or more variables. When you're working with formulas or literal equations, it's often helpful to isolate or solve for one of the variables in terms of the others. And so I'll show you what this means. So let's say I, let's just actually do this first example here. It'll make more sense. Alrighty, so Mrs. Briggs has 35 feet of fencing available to use for her vegetable garden. She knows that her garden will need to have a length of 7 feet to mirror her patio. Oh my goodness. That's embarrassing. Do I have a typo? I fixed it. If she wants her garden to be rectangularly shaped, how wide does it need to be to utilize all of the fencing? Sorry, I got so confused there because my answer key has the right word. So, well. So what we're gonna do, my biggest tip for these kinds of problems is always draw a picture. Alright, so she's got a patio here, like on the back of her house. This is her patio. Alright. Now her garden is gonna come out this way. Okay, so the fencing is gonna go around her garden. Okay, is needs to use 35 feet, right? Because she has 35. This is the perimeter, and it's equal to 35 feet. All right, well, we've got some other things at play here too. We know the patio length here is L long 7 feet. And so we're trying to figure out how wide does it have to be to use all of the gardening. So what we can do is if I just write this equation, perimeter is going to be 2 times length plus 2 times width. I would have to do a lot of work to be able to get width all by itself after I plug in my numbers. So often what we will do is isolate that W so that we could just plug in what we know and move on. So if I do this for you quickly, so I'm going to subtract this 2L from both sides, and then I'll divide by this 2 to get W on its own. This is going to look like W is equal to 1/2 P. If you're like, I don't know how you did that, don't worry. I'm going to show you on the next page. This is just getting through this example here, showing you what this would look like. So what I can do is plug in what I do know, right? I do know P here, the perimeter, is 35. And I do know the length of the patio that the garden's running along, right? That is 7. And so I'll be able to plug those in to find our width, or unknown. So let's see what this looks like. So when I start plugging those values in, I'm going to get that the width is equal to 1/2 35 minus 7. And so since we're dealing with measurements, I am just going to use decimal here. So this would be 17.5 minus 7, or 10.5 feet. So Mrs. Briggs Mrs. Briggs's garden needs T 10.5 feet wide. I realized I kind of messed up some of my color coding here, so I'm just fixing that really quick. Okay. Alright, and if I messed you up with my length and width being the way they are, it's because I drew my picture sideways, so I apologize. Math works out the same. Alright, so example 2 here, I'm going to show you what's actually happening here. So what we're going to do is use inverse operations to get variable by itself. So if I want to solve for b, that means that I want to find b here. And I want it to be all on its lonesome. Okay, I don't want anything else by it. So I'm going to have to use inverse operations to get rid of that 1/2 and that h. And so first thing I'm going to do is get rid of the 1/2. And how we do that is we will, oh man, and you're going to multiply both sides by 2. So I'll end up with 2a equal to b times h. Now again, we're still trying to get b all on its lonesome here. So right now it's being multiplied by h. So we will divide both sides by h. And we'll end up with b is equal to 2a over h. So again, that last step we did was we had to divide both sides by h to get rid of that multiplying by h. Alright, now you may notice that example 3 and example 4 are the same equation, because I'm going to show you 2 different ways that we can write this same equation, right? One is going to be solve for x in terms of y, and one is going to be solve for y in terms of x. So the first thing that we're going to do to get x by itself in this one is we kind of have to work from the outside in. So we have to remember those inverse operations like we have been doing. We need to get rid of this subtracting of y before we can get rid of, oh my goodness, that multiplying by 2. So we're going to add y to both sides. And we'll end up with 2x is equal to y plus 1. So as a reminder what we're doing here, we're going to add y to both sides. Remembering here we're using kind of that reverse PEMDAS. That reverse order of operations. Alright, well now x still is not alone, so we need to divide both sides by 2 to cancel that out. And so we'll have 1/2 y plus 1/2, or you could have left it like how it was before, whatever kind of is your teacher's preference. Alright, now remember example 4 starts out with the same equation, but now we're going to see what it looks like in terms of y instead. So to get y alone, first I have to get rid of this here. Here we're adding 2x, so I'm going to have to subtract 2x from both sides. Alright, so that will cancel. Careful that you don't lose your negative here, okay? We're going to end up with negative y is equal to negative 2x plus 1. So because we did not forget our negative here, okay, we have to multiply or divide both sides by negative 1. So I'm going to multiply by negative 1. Alright, so this will become positive y. Then I'm going to remember I need to distribute that to both terms. So if it's going to become positive 2x here, it also becomes negative 1 here. Alright, in this very last example here, we are going to solve for h. So what we're doing here is we are trying to get h all on its lonesome. So first thing I'm going to do is get rid of that fractions, because that fractions really kind of freak people out. Well, but you don't need to. So multiply both sides by 3 to cancel out that dividing by 3, that fraction right there. Alright, so I have 3v is equal to LWH. Now to get h alone, I'm going to divide both sides by length times width. And that will cancel, and I'll have H is equal to 3 times the volume divided by the length times the width. Alright guys, I hope you had a fantastic time solving these literal equations with me, and I'll see you later. Bye.